In 2017, scientists detected something that shouldn't exist, an event so fast, so violent, that it released more energy in a single second than our sun will produce in its entire 10 billion-year lifetime. We're talking about a cosmic collision that rewrote physics textbooks, created more gold than exists in our entire solar system, and proved Einstein right 100 years after his prediction. And it all happened in just 2 seconds. Today, you're about to discover the universe event that happened too fast. But before we dive into this insane event, you need to understand something fundamental about our universe. The cosmos doesn't rush. Think about it. A star takes millions of years to be born. Galaxies collide over the course of billions of years. Even a supernova, one of the most violent explosions we know of, takes weeks to reach its maximum brightness. The universe operates on timescales so vast that human lifetimes are barely a blink. But there are exceptions, rare, extreme exceptions. Events so powerful, so concentrated, that they compress unimaginable amounts of energy into moments shorter than a heartbeat. Events that make a supernova look like it's moving in slow motion. And on August 17, 2017, humanity witnessed one of these exceptions for the very first time. An event that didn't just challenge our understanding of physics, it shattered it, rebuilt it, and left scientists around the world asking the same question: how is this even possible? August 17, 2017, 12:41 UTC. Observatories across the planet suddenly light up with alerts. The LIGO detectors in the United States pick up ripples in space-time itself, gravitational waves. Then, less than 2 seconds later, the Fermi Space Telescope detects a powerful burst of gamma rays. Something extraordinary was happening in a galaxy 130 million light-years away. 2 neutron stars were about to collide. Now, let me paint you a picture of what a neutron star actually is. Imagine taking our sun, with all its mass, and crushing it down into a sphere just 20 kilometers across. That's roughly the size of Manhattan. The density is so extreme that a single teaspoon of neutron star material would weigh about 1 billion tons on Earth. These aren't just dense objects. They're the densest things in the universe that aren't black holes. And 2 of them were on a collision course. These cosmic giants had been orbiting each other for millions, possibly billions of years, slowly spiraling inward, getting closer, faster, tighter. But the final moments, those were absurdly fast. In the last 100 seconds before impact, they completed 2,700 orbits around each other, 27 complete circles every single second. That's faster than a helicopter blade, faster than a jet engine turbine. Objects with the mass of our sun, spinning around each other at a significant fraction of the speed of light. And then, collision in 2 seconds. Here's what happened. The stars merged in a catastrophic explosion that released energy equivalent to 10 octillion atomic bombs. That's a 1 followed by 28 zeros. The collision sent ripples through the very fabric of space-time, gravitational waves that traveled for 130 million years before reaching our detectors on Earth. The temperatures reached trillions of degrees. Matter was compressed beyond anything we can recreate in laboratories. A black hole was born. And here's the truly mind-blowing part. In those 2 seconds, that collision created more gold, platinum, and heavy elements than exists in our entire solar system. Every gold ring, every platinum catalyst, every rare element in your smartphone. All of it was forged in collisions just like this one, billions of years ago. 2 seconds, that's all it took. The time it takes you to blink twice, to take a breath, to say hello. In that microscopic slice of time, the universe rewrote the periodic table. Now, here's what left scientists completely stunned. Our most advanced computer models predicted that this kind of event would be fast. Yes, violent, absolutely. But the simulations suggested the merger process would take at least 10 to 15 seconds from the moment of first contact to final collapse. The reality, 2 seconds. Let me put that in perspective. It's like calculating a road trip should take 5 hours based on speed limits and distance, but somehow arriving at your destination in just 1 hour. You wouldn't just be breaking the speed limit, you'd be breaking our understanding of how speed works. And that's exactly what happened here. The universe showed us that cosmic events can be even more extreme. even more concentrated than our best theories predicted. Think about what this means. We have equations. We have supercomputers running simulations. We have decades of research and Nobel Prize-winning physicists checking the math. And still, the universe said, "You're not even close." This wasn't a small error. This was the cosmos telling us that there are mechanisms, processes, and physics happening at these extreme conditions that we still don't fully understand. The universe operates at the edge of what's possible, and sometimes it goes beyond that edge. But here's where it gets even more fascinating, because this 2-second event didn't just surprise us. It answered questions we've been asking for over a century. And if you're enjoying this journey through the cosmos, hit that subscribe button right now, because we're about to explore how this brief collision changed everything we know about the universe. This 2-second event fundamentally changed 3 pillars of modern science. Let's start with the most tangible one: the origin of gold, that wedding ring on someone's finger, the gold contacts in your computer, the platinum in a car's catalytic converter. For decades, we believed these heavy elements were created exclusively in supernova explosions. We were wrong. This collision produced approximately 200 Earth masses of pure gold in 2 seconds. Let me say that again. 200 times the entire mass of our planet in gold. And it wasn't just gold. Platinum, uranium, thorium, all the heavy elements at the bottom of the periodic table. They were all forged in this cosmic furnace. Every single gram of gold on Earth, in your jewelry, in your electronics, was created in a violent collision like this one, billions of years ago, in a galaxy far away. It took less time than sending a text message. Second, Einstein's ultimate vindication. In 1916, Albert Einstein published his theory of general relativity. Buried in those equations was a wild prediction. Violent cosmic events should create ripples in spacetime itself, gravitational waves. For 101 years, we searched for direct proof. We built the most sensitive instruments ever created, and we waited. This event gave us that proof. For the first time in history, we detected gravitational waves and saw the light from the same event. We didn't just hear the universe, we saw it too. Einstein had been right all along, and it took a century to prove it. Third, the birth of multi-messenger astronomy. Before August 2017, we observed the universe in one way: light. Visible light, radio waves, X-rays, gamma rays, all different forms of light. But now we can detect events through gravitational waves as well. It's like the universe was a silent movie for all of human history. And suddenly, someone turned on the sound. We're not just watching the cosmos anymore, we're listening to it. We're feeling it vibrate through space-time. And this opens up entirely new ways to study black holes, neutron stars, and the most extreme physics in existence, all because of 2 seconds. But here's something even more profound to think about. While you were having your morning coffee on August 17, 2017, or scrolling through your phone, or sitting in traffic, the universe was literally transforming itself. 2 objects that had been dancing around each other since before dinosaurs walked the Earth finally collided. And in 2 seconds, shorter than the time it takes to breathe deeply, more precious metal was created than exists in our entire solar system. Now, here's the part that gives me chills. The light from this collision traveled for 130 million years to reach us. That's not a typo. 130 million years. When those 2 neutron stars began their final death spiral, dinosaurs were still the dominant species on Earth. Mammals were tiny, insignificant creatures hiding in the shadows. Those gravitational waves rippled through the cosmos while the dinosaurs went extinct. While the first primates evolved, while humans learned to walk upright, discovered fire, built civilizations, invented writing, developed science, and finally built machines sensitive enough to detect them. All of that happened while this cosmic message was traveling toward us, and we were here, right here, at exactly the right moment in history, with exactly the right technology, in exactly the right place to catch it. What are the odds of that? We exist in this tiny sliver of time where we're advanced enough to detect the universe's secrets, but still young enough to be amazed by them. Isn't that incredible? To be alive at the exact moment when humanity can finally not just see the universe, but feel it. So the next time you look up at the night sky, remember this: the universe isn't just something sitting out there, static and unchanging. It's a living, breathing machine where incredible events happen every single second, most of them too fast, too distant, or too faint for us to detect. But sometimes, just sometimes, the cosmos puts on a show. An event so powerful, so perfectly positioned that even across 130 million light-years of empty space, we can capture it. And this 2-second event, it didn't just create gold. It created knowledge. It expanded our understanding of reality. It connected us to the universe in ways we never thought possible. It reminded us of something fundamental. No matter how fast the universe moves, no matter how extreme its physics, no matter how vast the distances, we humans always find a way to keep up. If this story fascinated you as much as it did me, subscribe to this channel so you don't miss the next cosmic mystery we're going to unravel together. And tell me in the comments, what universe event would you like me to explain next? Until then, remember, the universe might be fast, but human curiosity is faster.